Good evening, everyone. This is the post-launch news conference for the SpaceX SES-10 mission. Here tonight to give us a status of the launch and our mission is Elon Musk, CEO and lead designer, SpaceX.
All right.
And Martin Hallowell, Chief Technology Officer, SES. We'll start now with Elon Musk.
All right, thanks. Well, I already gave some basic remarks on the webcast, but this represents the culmination of 15 years of work at SpaceX to be able to refly a rocket booster. The most expensive part of the whole mission from a launch standpoint is the boost stage. That represents, depending on how you count it, up to 70% of the cost of the flight. So being able to refly the rocket booster, ultimately with the only thing changing between flights being propellant, means that at least for that portion of the flight, the cost reduction potential is over 100, over a factor of 100. In fact, all of the propellant cost for the flight is only 0.3% of the cost of the rocket, of the cost of the mission. So even when you factor in maintenance and capitalization of the cost of the rocket, the potential is there, just as it is with air flights or road travel or really any means of transport. The potential is there for over 100-fold reduction in the cost of access to space, which means if we can achieve that, if SpaceX and I think hopefully others will also do the same, it means that humanity can become a space-faring civilization and be out there among the stars. This is what we want for the future. So, yeah.
Well, absolutely wonderful day, absolutely astounding. What an amazing mission for SES-10. It's a perfect mission. We have a perfect orbit. We have acquisition of the satellite. We actually got acquisition of the satellite around about 35 minutes earlier than we expected. And in fact, all the three missions that we've had from SpaceX, this is absolutely the most calm, no problems whatsoever, absolutely smooth mission. So it really couldn't have gone better, and we are hugely excited by this. You know, to be part of this, I think we made a little bit of history today, actually, and just to open the door into a whole new era of spaceflight, and to be part of that, I feel very privileged, and it's great thanks to Elon and all of the people of SpaceX that have really made this possible, and just pushed us forward to the next stage. So bring it on, fantastic.
And Ron, I'd just like to say thank you for taking a chance on SpaceX. This is not the first time you're taking a chance on us. And I just really want to say thank you for having the faith.
Thanks, Elon. But actually, some of the people asked me the other day, they said, "Oh, you're taking a big risk."
Right.
I said, "Look,
SES got a lot of flack, by the way.
we got a lot of flack, but it is, as I said to some of you guys the other day, I said, you've got to decouple the emotion from the engineering.
Right.
You know, and that's the most important thing. And the engineering team that Elon has working for him is really second to none. And he asks very simple, profound questions, and he gets very good answers. And you know, the proof is in the pudding. Here we are. We did it.
Yeah.
We did it together.
Thank you.
That was absolutely fantastic.
So we're now going to take some questions here in the room. When you're recognized, please state your name and your affiliation. And I'd ask you that you also please wait until the microphone comes to you. We do have a limited amount of time this evening, but I do want to note that, but we'd like to begin now with Marcia Dunn.
Marcia Dunn, Associated Press for Mr. Musk.
Hey, Marcia.
Will you refly this booster, and when's your next flight of a reused booster, whether it's this one or another one?
We have to have several reflights planned for later this year. If all goes well, I think we may fly as many as 6, maybe do as many as 6 reflights. For Falcon Heavy, 2 of the boosters, the 2 side boosters are reflown boosters. So that alone will be two cores right there. In fact, that'll be an exciting mission, one way or another. Hopefully in the good direction. We're not going to fly anything on. We'll probably fly something really silly on the first flight of Falcon Heavy. because it is quite a high-risk mission. But in terms of things to look forward to later this year, I think that'll be quite fun, because the two side boosters will come back and do sort of a synchronized aerial ballet and land, two of the side boosters will land back at the Cape. So that'll be pretty exciting to see two come in simultaneously, and then the center core will land downrange on the drone ship. It all goes according to plan, which like rockets.
And what about this one? Will you fly this one again?
Well, this one we think this one sort of has some historic value. So we were thinking of seeing if perhaps the Cape might like to have it as something to sort of remember the moment. So we're going to present it as a gift to the Cape.
Bill Harvey, CBS News. Elon, I got an email from a retired shuttle engineer who goes all the way back to Apollo. And his email was simply, he said, it ain't bragging if you do it. And what message do you think this mission gives to your competitors? You mentioned the space industry earlier, but it seems like, well, I'll ask you, I mean, do you think other people are going to follow in your footsteps, or do you think this is something you're going to be doing exclusively in the near term?
Well, I think hopefully this will inform the decisions of other space organizations. And, you know, because really this has been thought to be either really too hard or not really feasible. And I think we've shown that something that a lot of people thought was somewhere between impossible or you just shouldn't do it to, hey, it works. And then I think really, in order to be competitive in launch classes, I think it's going to be necessary for other launch companies to do the same thing. Just as you can imagine that if we were an aircraft company selling aircraft that could be flown many times, and everyone else was selling aircraft that could be flown once, well, I mean, you know, that's not a very competitive position to be in. Like if you said, like, you know, so you really want to have the aircraft that can be flown lots of times. And so I think that's, you know, once it's clear that something can be done, then I think that will encourage others in that direction, and I hope it does. Because I think there should be, it shouldn't just be SpaceX, there should be many launch companies that succeed.
Irene, thoughts?
Hi, thanks for coming over and congratulations. Irene Falks with Reuters.
Yeah, Irene. I've known you for like 10 years. Maybe more.
Do you have other customers that were not as perhaps brave as Mr. Halliwell here that are now signed up?
That's safe to say.
And I
Yeah.
think you tell us a little bit about
Sure.
what you think the life-limiting factor will be now in the first stage. How many times you think you'll be able to fly?
Sure. Well, it's we're really, I'd like to say NASA's been incredibly supportive in terms of pushing the envelope of new things. And then on the commercial side, SES has been by far the most supportive. Again, couldn't say enough, thank you enough. So the next thing is to try to figure out how do we achieve a very rapid reuse with minimal refurbishment and minimal, without any sort of hardware changes on the vehicle. So with this being the first reflight, we were incredibly paranoid about everything. So we sort of, the core airframe remained the same, the engines remained the same, but any sort of auxiliary components that we thought might be slightly questionable, we changed out. So now our aspiration will be 0 hardware changes, reflight in 24 hours. The only thing that changes is we reload the valve. We might get there towards the end of this year, but I think if not this year, I'm confident we'll get there next year.
So without no inspections, you just would refly?
Oh, you look at it, but you have a day.
Yeah.
So, we'll certainly expect it, and there will be quite a lot of onboard health monitoring. So there's a lot of sensors on board to say whether things are good or not. So the onboard health check system, there's a lot of sensors that confirm the health of the rocket. Okay, just like an aircraft, really.
I'd like to take a question from the phone, please. I think we have on the line Chris Davenport from the Washington Post.
Oh, hi, Elon. Thanks for taking the call.
Hey.
I guess I want to follow up on Bill Harwood's question, because you had said this was a real significant moment, not just for SpaceX, but for the industry as a whole. Blue Origin and others are obviously working on reusability. We recently just showed an artist rendering of a ship that looked really a lot like your drone ship. And I wonder what your reaction to that was and to their plans, which really seem to be tracking theirs.
Well, it seems to be, I mean, what's it saying about the best form of flattery? But actually, I think it's good. Frankly, I think if a company shows that a path is working, then other companies should copy that. I mean, it would be silly not to. We wouldn't want to arbitrarily not do the right thing simply because some other company has. So I think it is the wise move to well, obviously we think it's wise move to the decision we made, but is that rapid and complete reusability of rockets is really the key to opening up space and becoming a space-faring civilization, a multi-planet species, and having the future be something that's incredibly exciting and inspiring that we'll look forward to.
All right, one more question from the phone, please. It's Dave Mosher from Business Insider.
Can you guys hear me okay?
Oh, actually, one little bit of breaking news, which the fairing, the big nose cone at the top of the rocket, that actually successfully landed as well. So that was definitely a cherry on the cake. So we actually have a parachute that the fairing has its own thruster control system and a steerable parachute. It's like its own little spacecraft. So the thrusters maintain its orientation as it comes in, as it re-enters, and then we throw out a parachute, and the parachute steers it to a particular location. And so I just was showing a picture of an intact fairing path floating in the ocean.
Yes, logo one.
Yes, sure enough.
It's the wrong half.
It's the half without the logo.
US flag on it.
But yeah, that's really exciting because I mean, just that fairing, which is over 5 meter diameter. It's like you can fit it like a bus inside that fairing, and it costs $6 million to make that fairing. And at one point we were like debating, should we try to recover it or not? It's like, guys, imagine you had $6 million in cash in a pallet flying through the air, and it was going to smash into the ocean. Would you try to recover that? Yes, yes, you would. So rather than have to smash it to tiny pieces, that's looking quite promising. So so like what we'll have is kind of like a bouncy castle for it to land on, and then aim to reuse the fairing as well. And then the only thing left is the upper stage, which we didn't originally intend for Falcon 9 to have a reusable upper stage, but it might be fun to try like a Hail Mary and, I mean, what's the risk that can happen if it blows up? It blows up anyway.
Hang on, we need to discuss this.
Yes.
Dave, did that get to your question? Because I want to make sure you got your question.
You answered part of my question, the second stage. But I wanted to know, like, how this fits in, now that you've done this, how does this fit in with your grand scheme, your grand plan here to get to Mars, to launch astronauts and things like that? How does this affect those plans? And will you re-fly boosters with astronauts on top? And yeah, I guess how does this affect the Mars plan as well?
Well, I think that this is really a critical part of the Mars plan. If you consider the goal of Mars not to be a single mission, but one where we establish a self-sustaining city on Mars. In order to do that, there's some threshold cost in terms of the cost per ton to the surface of Mars that has to be achieved in order for that to be feasible. If that cost per ton exceeds the gross world product of Earth, which it currently does, then that's obviously not going to happen. There needs to be at least a 100-fold, if not perhaps 1,000-fold reduction in the cost per ton to Mars. Actually, maybe 10,000-fold. And reusability is absolutely fundamental to that goal. So this, I think, is a very helpful proof point that it's possible. And I hope people start to think of it as a real goal to which we should aspire to establish a civilization on Mars. It's really, this is not just about humanity, it's about all the life that we care about.
I'd like to go back to the room for questions. This is Stephen Clark, please.
Hi, Elon. Stephen Clark from Spaceflight Now. Thanks for coming by. A couple of questions. First of all, do you have customers who have signed up for a reused rocket and future reused booster?
We have one sitting right here.
Well, beyond
Besides
Mr. Hallowell.
Besides, yeah, there's currently excluding Falcon 9, excluding the Falcon Heavy flight, which is just basically on SpaceX's dime that nobody's paying us for that because it's a demonstration flight. It's essentially a test flight. That's two of the reused boosters. There are, I think, 3 or 4 others that have signed up on a contingency basis. Like, if this one works, then sure. And so I think probably we'll see more of those customers being willing to do on and I should use the right terminology, flight-proven booster. That's right, flight-proven.
Touche, and I'm a follow-up as well. Can you update us on where Falcon Heavy is? I know you're testing things in McGregor right now.
Sure.
Where are you at with qualification of hardware, and what's driving the launch date, and when do you expect it to debut here?
Sure. Well, Falcon Heavy is one of those things that sounds, at first it sounded easy. We'll just take 2 first stages and use them as strap-on boosters. And actually, no, this is crazy hard. And required redesign of the center core and a ton of additional hardware. It was actually shockingly difficult to go from a single core to a triple core vehicle. But we're now done with the testing, and the cores are in final fabrication. I think they finish in about 2 or 3 months. So our expectation is probably a late summer launch of Falcon Heavy.
James Dean.
Oh, thank you, James Dean, Florida today.
I should still say, our priority is launching our. Since we have a backlog because of we had a whole gap of time as we recovered from the issue that we had last year. Our priority is, of course, making sure that we launch our customers. So Falcon Heavy necessarily is a second priority to making sure that our customers' needs are met.
Thanks, James Dean, Florida today. Elon, how confident were you going into the countdown and through that first booster phase? And then just regarding reusability, one of the concerns, I guess, is about the flight rate you'll need to make it pay off. Even those who are for it, say, well, you got to launch, this many times to make it worth it.
Sure.
So for you, what do you think is today the day to celebrate? Or are we, maybe years from what flight rate do you need to reach, and how long will it take?
It's something true that if you just say how much effort has SpaceX put into developing reusability, and nobody was paying us for reusability, so it had to be on our own dime. I think it's probably at least $1 billion that we spent developing this, so it'll take us a while to pay that off. And then we need to get really efficient with the reuse of the booster and with the fairing. So I would expect the economics to start becoming sensible next year. That's, yeah, pretty close. And we expect the boosters to, with no refurbishment, be capable of 10 flights, and with moderate refurbishment, be capable of 100 flights. So you can imagine that, if the cost of the rocket is, say, $60 million, really, we're not reusing the whole thing, but would be with the fairing, assuming the fairing reuse works out, and as we optimize the cost of the reuse of the booster, you're really looking at maybe 3/4 of the rocket cost dropping by an order of magnitude and maybe more.
Were you confident going into today?
Well, I did have like 2 boxes of Xanax. That might have helped. I was oddly. I felt calmer than I should have been. I think, why am I should really feel. I was actually, oddly enough, I was nervous that I wasn't nervous enough. Sort of nested level of fear, nested fear. But I felt still rather calm, and it worked out as well as one could expect. It's really credit to the SpaceX team for doing an amazing job. Go ahead.
Lauren Grush with The Verge. I was wondering if you could talk about the new facility that you guys have on the Cape and how that will work into the refurbishment process of rockets. And if we're addressing rumors here today, I was wondering if you might be able to talk about the robot that we've seen on the drone ships lately.
What robot? What are you talking about? We have a refurbishment facility at the Cape. Most of the refurbishment will be done at the launch site itself. So we've got space at 39A and we've got space at 40, and then there's also a whole separate sort of rocket hangar actually for the rocket fleet. Rocket fleet's getting kind of big, so there'll be sort of like a forest of rocket boosters, because we've got another 20 flights or something this year, something in that order. If most of those succeed, we're going to need quite a big hangar, and that's So there's facilities for that, and the robot thing is in order to secure the rocket remotely, because we can't put any people on board if the rocket's sliding around because it's too dangerous. So those little droids that people have seen are in order to remotely secure the legs of the rocket. And so the rocket is stabilized, doesn't move around, and even in high seas, we can still have a crew board the drone ship and save the rocket.
Can you say when we'll see that one in action?
Actually, it was certainly within the next few months. But today was fine, because the seas were so calm, the rocket's not moving around, and so it's not, you don't really need the droids. But it's kind of more like the heavy seas situation. We had that one case where it was quite stormy, and the booster was like sliding from one side of the drone ship to the other. It's like the only thing that stopped it from going overboard was there was like a lip on the edge. So it was like bang, edge, slip, and then slightly to the side, bang, edge, slip. But it made it to port.
Rob.
Hello, Robin Simmanuel with the New York Observer. Can you give us an update on the development of the interplanetary transport system and what's next in terms of what's the next component that'll be tested? Following the carbon fuel tank and the Raptor engine, what's next?
Yeah, so I will provide an update on the design of the interplanetary transport system. That interplanetary transport system also includes the propellant depot on Mars. That's why it's sort of, I actually don't usually like the word system, but you can't call it a rocket if it includes a propellant depot. So the Mars Colonial Transporter or Mars Transporter or Interplanetary Transporter, we've come up with a number of design refinements, and I think we'll probably be ready to put that on the website within a month or so. Yeah.
Just one follow-up. The time frame has kind of shifted since Guadalajara. I was wondering if you guys had any updated time frame of when you think that first mission will be launched, and if I'm correct, the first one is uncrewed, correct?
Yeah, the first ones will be uncrewed. I don't want to steal thunder from that announcement because I think I'm pretty excited about the updated strategy since Guadalajara. I think it makes a lot more sense, and we have to not just get it done technically, but figure out how to get this done without going bankrupt. So it's like our goal is to get people on Mars before we're dead and the company isn't dead. So like neither one can die. Ideally, because we don't want to be so take so long that we're dead by the time it happens, and we don't want to kill the company in the process. So we have to figure out not just solve the technical issues, but the economic issues. And I think the new approach is going to be able to do that, hopefully.
I'd like to get back and take some more questions on the phone. I think next on the line is Alex Knapp from Forbes. Go ahead, Alex.
Hi, Elon. Thanks for taking my call. I have to ask, before I got the fourth question, what's the pricing discount on a flight-proven launch option versus a standard option?
Actually, we're trying to figure that out, but it will be a meaningful discount. We do have to pay off. We'll figure out some way to pay off the development costs of our reusability. So the price discount won't be as the price discount won't be as much as the cost savings, because we need to kind of repay the massive development cost. But it'll certainly be less than the current price of our rockets, obviously, and will be far lower than any other rocket in the world.
Thank you.
The next question is also on the phone. It's Carrie Sheridan from Agence France Presse.
Hi, thanks for taking my call. Could you just repeat for me, I'm not sure if I heard you correctly, about how many times might you be able to reuse one of the boosters, both for one that's been reworked a lot like this one and one that has undergone minimal refurbishment? Thanks.
Sure. The design intent is that the rocket can be reflown with zero hardware changes. You know, the only thing that changes is you reload propellant 10 times. And then with moderate refurbishment that doesn't have a significant effect on the cost, it can be reflown at least 100 times. Right? Actually, really, I mean, we can make it 1,000, but it's probably there's no point in that. I think. For the Mars vehicle, the booster will be designed for 1,000 flights or more.
Let's go back into the room. Ken Kramer, please.
Hi, thanks. Ken Kramer, Universe Today. Thanks for doing this and congratulations on the flight. So, my question is about the refurbishment. And what are the lessons that you've learned? You got 8 cores back and you got 1 today. There has to be some things that are used more, that are more prone to failure. So what are those? What are the things that keep you up at night? What are the lessons you've learned and implemented? And the second question would be, for your moonshot, are you going to have a vigorous science program, any science program, and can you tell us about it? Thanks.
Sure. Well, I want to make sure we don't widen this press conference into the all things, because today is really about the fact that the rocket booster was reflown and succeeded. And so I don't want to contain things to that, because there's lots of other exciting things in the future. But this would be a very long press conference if we did all that. And some of the technical elements that are the most tricky, I think, for reuse is the base heat shield of the rocket, the grip fins. If you saw on the webcast, you may have noticed that the grip fins were lighting on fire. So we actually have a new design for the Griffin, which is quite a bit more advanced than the current one, and I believe it will be the largest titanium forging in the world. So it's a special alloy of titanium that's very good at high heat flux, whereas this Griffin is made of aluminum, but it's covered in thermal protection. So it's but it gets so hot the thing lights on fire a little bit, which is not great for use. But the new Griffins should be capable of taking a scorching and being fine. And they'll also have significantly more control authority, so that should improve the reusability of the rocket. But it will actually improve the payload to orbit by being able to fly it at a higher angle of attack and use the aerodynamic element of the rocket to effectively glide like a fixed cylinder. Like it actually does have a LVD of roughly 1 if flown at the right angle of attack. But you need a control authority, particularly pitch control authority, that's higher than we currently have to achieve that. So, so Griffin's base heat shield, paint, I guess. Paint can get a little toasty, so maybe having more of a thermal barrier coating instead of paint. It's like, and there's a million little things. I think we've got the base heat shield thing addressed. We've got a good plan for the Griffins, and then there's like a bunch of little things that need to be ironed out. But overall, I think we've got a plan to achieve the 24-hour zero hardware change reusability by next year.
Next year, okay.
Another question in the room, please.
Thank you.
How about Brendan Byrne from WMFE, the NPR affiliate here at the Space Coast?
Yeah, thanks for taking my question. With that said, with those challenges, and I know it's still a little bit early, with the data that you're getting back from this booster, is there anything that stands out in your mind that you're worried about, or how's this booster doing? How do you know?
I mean, I was looking at the telemetry all the way up and down. Everything looked great. It looks really good. I mean, just kind of eyeballing it, I think that like the only things that would need to be addressed on this booster to reflag would be to replace thermal protection on the Griffins and on the base heat shield, and to repaint areas of the rocket where the paint bubbled. I'm not aware of anything else that would need to be.
So fixable.
Yeah, absolutely. And we've got a plan for all of those elements.
Thank you.
Yeah.
More questions in the room? How about Tim Fernholz from Course?
Yeah, in fact, I'll just elaborate on that. Like one thing that's not sort of well understood about spaceflight is that altitude is really not the thing that matters. It's velocity. It's a little counterintuitive because people see a rocket pointing up and it goes straight up, and you think, well, okay, the way rockets go to space is they go straight up, and then suddenly gravity stops at some point, and that's how you get to space. That's not at all how it works. That's why we have the word orbit. So the way that things go up and stay up is they zoom around the Earth so fast that the outward acceleration, outward radial acceleration is equal to the inward acceleration of gravity. They null out, and that's why you don't fall down. And the thing that really is incredibly difficult to deal with is the heat of reentry. Now, generally this is a good thing because it means that we don't get all pummeled by meteors all the time because they get burnt up in the upper atmosphere, so it's good. But then if you want to make a rocket come back and not also be vaporized, that's hard. And you can't have this really heavy heat shield or you won't get any payload to orbit. So the trick is to figure out just the right level of armor in just the right places with advanced materials and the best analytical techniques, so that you have all the thermal protection that you need, but it's not so much that you don't have any payload to orbit. That's really the trick of it. Actually, missions like the one we just did are the hardest missions because anything going to geosynchronous transfer orbit means it's a high velocity mission. And that means the booster is coming in really hot. It's coming in fast, which means it's coming in really hot. The peak heating is as the cube of velocity, which is really nutty to think about. It means that, say, the heating difference between Mach 1 and Mach 8 is 500, roughly. This crazy heating difference. And then, of course, once you pass the melting point of metals, then, well, your thing melts and explodes. So that's really it's dealing with that velocity of reentry. That is the difficult thing.
Hi, gentlemen. Tim Furbels from Quartz. Martin, I wanted to ask you to follow up on something you said earlier about SES deciding to back SpaceX. You said you had to separate the emotion from the engineering. What emotion are you talking about? Is that about SpaceX or about innovation in the aerospace industry generally?
No, it was really referring to the comments that we had over the last couple of days when we spoke to the press and we spoke to the people and made that little press conference and such like. A lot of people came back and said, you're taking an inordinate risk here. You have an extremely expensive spacecraft, has a very important mission to do in Latin America. Aren't you taking a huge chance here? And what I was trying to react to there is to say, actually, I don't think we are. Because we'd actually worked through this problem. We worked very, very closely together with SpaceX. And that's really probably why we've done more of these type of missions with SpaceX than anybody else. We've been the first on Proton, but all this type of stuff. But with SpaceX, we have a certain transparency, and we have a certain depth of relationship, and also access to engineering specifics through our US citizens that allow us to be able to have that confidence in the fact that the engineering is good and that we can go ahead with such a mission and make that investment and be happy that this hugely expensive spacecraft can fly on this particular booster. So that's really where I'm coming from. You've got to get away from the idea that it's second-hand, it's maybe, it may make it, it may not, no. That doesn't interest us whatsoever. You actually have to go into this really with a sang-fire. You have to go into this really cold-blooded and just work through the various different issues, understand the testing, understand the engineering associated with this, and then you make your decision. That's exactly what we did. We have 3 more flights this year with SpaceX. On 2 of those flights, we're considering now moving them to pre-flown.
Great, that's good. I didn't know that.
Oh, we need to talk about it.
Yeah, sorry.
Just a question for you, Elon.
Absolutely.
In Mexico, you showed us a photo in your presentation of a very early days at SpaceX with a mariachi band and 12 people in a hallway.
Right.
Since
From mariachi band to here.
Where are you? Since that time, you've mentioned 15 years and spent a lot of work.
Yeah.
I'm just curious, is this a day of personal satisfaction for you? Do you feel vindicated in this mission to lower the cost of space access?
Yeah, this is a huge day. My mind's blown. I mean, frankly, I was really quite speechless after it all happened. It's a culmination of a tremendous amount of work by a very talented team. I can't credit to the engineering team and production team at SpaceX and the launch team for what they've achieved.
Maybe just a couple to that. I think when we did the SES-8, which was the first commercial GTO mission that we did with SpaceX, I made the comment that the industry would be shaking in its boots. Oh, I think it's shaking now. I really do.
It will spur change for the better.
Hey, that's good.
Another question in the room. How about Marco Santana from Orlando Sentinel?
Hi. I was wondering a little bit off of what he just said. Can you try to put this in perspective? I mean, you've had a successful career, obviously successes and failures as an entrepreneur, but can you put this in perspective on where this fits in with all of that? And the second question I wanted to ask briefly is, why are you keeping the rocket at the Cape? What went into that decision to keep it here?
Well, it's just this one booster. Because it has some historic significance. We thought having it remain at the Cape would be good. The future ones would, the future ones would probably remain at the Cape too. They would just be going through just flying a lot. Yeah. So we're building up the space fleet, basically. Yeah, so what was the question?
Where do you fit this in your whole career milestones, I guess?
Definitely one of the best things ever. Sure. That's 50 years of like a lot of less written years. Jeez.
More questions in the room, please?
Hi, Thaddeus Zuri with the Utica Phoenix, and there's been a lot of history. There's been quite an amount of history made from LC 39A.
Yeah, I mean, it's like Times Square. I mean, it's like I mean, when NASA said that they would lease it to us and allow us to use that pad, it was a incredible honor because I mean that's obviously where the Apollo 11 moon landing. That's where they launched from. Yeah, coolest launch location that I could possibly think of. Yeah.
And was this part of your design to lease this pad, or did this?
No, I mean it sort of came up, and NASA asked us if we had interest, and we're like, hell yeah.
More questions in the room, please. How about Zubaro Marcos from Elmhurst in the back?
Thank you. SpaceX currently launches satellites and cargo to the International Space Station. So today's achievement, how could open the door to many new endeavors in space?
Well, I think the key is going to be reduction of the cost of access to space. I mean, I think over time, the current architecture of Falcon 9, I think, will certainly allow for dramatic reduction in the cost of access to space. But then, looking ahead to our next generation vehicle, the big rocket, the kernel code name of BFR, Big Falcon Rocket. I don't know why people laugh. That vehicle, I think, is really taking all of what we've learned and creating something which is fully reusable it really, in fact, the primary booster is being designed to reflight within less than an hour. You could fly once per hour with the primary booster. And I'm really confident that architecture, with a high flight rate, which I think will occur, can achieve 100-fold reduction in the cost per unit mass to orbit, or really anywhere in the solar system. So I think what today really, what the significance of today is, I think proving that it's possible to do that, at least with the primary booster, and then we'll show next with the upper stage as well. And that I mean, at this point, I'm highly confident that it is possible to achieve a 100-fold reduction in the cost of space transport, and maybe more, maybe better than that. And so it means for the same budget, we can do 100 times more things. Mind-blowing, realistic. Next level.
Next question from Greg from Channel 13. Greg, hold on, please, in the back.
Congratulations, Greg Flow, News 13. Was wondering, with your kids here, is this an example of recycling the environment, recycling boosters, teaching them about the environment? Personal dad thing?
Well, there was like just potential for historic moments, so good to have the kids have them see it directly, and hope they had a good time.
We could tell.
More questions in the room, please. How about?
We'll just take a couple more questions, I think. Yeah.
Stephanie Siegel from NBC News, please.
Hi, Elon. With reusability now an option, how will you decide which missions will be using these flight-proven rockets versus first time, or is it solely based on customer request?
Well, it's the customers that are willing to take a flight-proven booster, or yes, some will still want to see a lot more flights before they're comfortable with what we call a flight-proven booster. They may use a different term, but it does seem as though we're like, we may do maybe half a dozen or more flights of a reflown booster this year, and then next year probably double that, and then I would expect that for the Falcon architecture, over time probably 3/4 of our missions or more are with the reflown booster.
Maybe as an operator, I could add to that. My belief is within 24 months, people like SpaceX, well, SpaceX specifically, will offer a service to orbit, and it'll be irrelevant. It'll be irrelevant if it's new or it's pre-flown.
Yeah.
It'll be irrelevant within 24 months. That's what this means today.
Yeah, the goal is to make this normal.
Yeah.
Right. It's just normal. Like, what are you talking about? Like, of course the thing comes back and lands. Like,
I think so.
Why wouldn't it?
We have time for one more question, I think, in the room here, please. How about in the very back, right there? Yes.
Chris Gebhardt with NASA Spaceflight. In terms of more short-term reusability efforts, how does this sort of conform to the Block 5 upgrade to Falcon 9? And for the Falcon Heavy side boosters, is late summer also an indicator of when Slick 40 will be back, since we heard that Falcon Heavy wouldn't go from 39A until Slick 40 was back up?
Wow, you really understand the detail. You're really in the details there. Yes, that's all approximately correct. So we need to get 40 up and running again, so that we can start doing single stick flights from 40, which allows us to do the heavy flights from 39A. So that necessarily 40 would have to be reactivated before 39A was in use for Falcon Heavy. And Falcon Heavy, I really want to emphasize, is a high risk. That's a high risk flight. 27 engines are lighting simultaneously. So it's a lot of engines. I mean, technically it should be called the Falcon 27. We thought that maybe that would sound too scary, so we called it Falcon Heavy. So certainly we wouldn't want to take those, something going wrong with that pad and then having no pad on the East Coast. So we're going to get 40 up and running, confirm that's good, and then we can launch Heavy from 39A. Block 5, the nomenclature I think we're probably not using the right nomenclature, because it's more like a point release than. It's Block 5 would be more like version 2.5 of Falcon 9 is probably the most accurate way to think about it. And the most important part of Block 5 will be operating the engines at their full thrust capability, which is about 7 or 8%, almost 10% more than what they currently run at. A number of other improvements to have reusability go smoothly as well, like the forged titanium grid fins. So it'll bring in a bunch of other factors. Block 5 or arguably just version 2.5 will also incorporate a number of elements that are important to NASA for human spaceflight.
All right. With that, we'll conclude our post-launch news conference for the SpaceX SES-10 mission. For more information, you can go to spacex.com or ses.com and follow us both on social media.
All right, thank you, everyone. Thank you.